So in your challenge 2 and 3, as I mentioned in class, I would like you to track the energy that is being used in those basins for your particular designs. And so the parameters that you can track, and I'll show you where those are located at, options. So you got the oxygen uptake rate, OUR, and all this is again in Chapter 5 in some of the oxygen transfer sections. Around page, let's see here, page 425 in our oxygen transfer section. So oxygen uptake rate, and you can look at that or monitor that. Milligrams of O2 per liter per hour, and so that would be the rate or the uptake rate. Oxygen transfer rate, how much is being imparted into the process. That would have units, these are English units, in pounds per hour, or you might see it in metric units, kgs of oxygen per hour in that particular system. And in particular, look at page 429, equation 555 for that specific. And so it's got the standard oxygen transfer rate and the actual transfer oxygen rate, actual AOTR and SOTR. And it goes through the derivation of how that's done. And then we also have the standard oxygen transfer rate. That would be at 20 degrees C. Oxygen transfer efficiency, OTE, is the efficiency, how much percent. So as you put in a certain amount, how much of that is actually effectively utilized or imparted into the system. And of course the standard oxygen transfer efficiency at 20 degrees C, and that would be a percentage. And then you've also got an opportunity to monitor the air flow rate, and that would be in cubic feet per minute. And so we have those in our parameters here, and so what we need to do is go into BioWin. And so this is an example of looks like the south plant, and we have an anaerobic, anoxic, aerobic, anoxic basin, and then followed by an aerobic basin. So we have two aerobic basins. I'm just going to click on the first one here for this example. And so if we go down to the bottom, the power dissipation, and I'll highlight this area. I can't use my marker here, but down at the bottom we have the mechanical mixing at 25.37 horsepower per million gallons. And so depending on what our flow rate is through this plant, looks like this plant is a 2 mgd, so we just multiply that by 2. And then for air, 44 horsepower per million gallons of flow. And so that's how many horsepower would be required for that first aerobic basin. And then our second aerobic basin, we again have mechanical mixing at 25.37 horsepower per million gallon, and the airflow for those requirements, how many horsepower would be needed. You've also got these monitored here, oxygen utilization rates, OTR, how many pounds of oxygen per hour, and airflow rate, and how much is being used, standard temperature, pressure. And so you can also go into your monitoring stages here and actually track these things. And so if we double click here, go to monitor items, and we can, so right now we just have the oxygen transfer rate checked, but we can actually check the remainder of these boxes. And we could do that for each one of these aerobic basins to look at how much oxygen is being used in that system and related to horsepower. And so what you really need to track is what I have down here at the bottom, the power dissipation, how much of that power is being used. And so we would want to model that and track that probably in a summary table for your various options and try and optimize, the least amount of power that would be used in each one of these particular scenarios that you are looking at. That should help. Thank you.